Salts. When we talk about salts, what are salts? Salts are ionic compounds formed when a metallic ion, which is called a cation, or ammonium ion, which is NH4, replaces one or more hydrogen ions of an acid. All right. Let's take an example. This is I want you to understand
Can you
first.
go up?
I want you to first understand this and then you can write. We have zinc hydroxide, ZnOH2. Solid. We have H2SO4 aqueous. This is an acid. When the reaction takes place, we see that zinc has replaced the hydrogen, and this is what our equation is all about. You understand this? All right. So how, if you look at the salt zinc sulfate, basically it is of two parts, right? There is a sulfate over here, and this sulfate came from acid. Always keep this in mind that in a salt anion comes from acid. So we know that salt is a mixture of a anion and a cation. It is an cation and anion chemically combined together, or in other words, a metallic ion and a non-metallic ion combined together. Always keep that in mind. The non-metallic ion always comes from the acid. Non-metallic ion comes from the acid. All right. Now, on the other hand, we have zinc. We know that zinc, basically, this is something like this, right? And always keep this in mind: the cation in a salt, or you can say the metallic ion, is always from the base. You get it? Whenever you're looking at a reaction, always, if you want to make a salt, if it says salt, it's very easy. You can just bring the metallic ion, or the cation comes from the base, and the anion for that particular as a salt comes from the acid. Is this clear to you?
Yes.
Right? So if you look at it, this is a 2 positive, and this is going to have a oxidation state of 2 negative, right? This is how this is formed. And you know that salts are ionic compounds. It means they are going to form crystals and lattices. All right. You can write this down now, inshallah.
Okay, can you go?
So some examples for this can be, let's say, let's say calcium chloride. Calcium chloride, obviously, we know that this is going to be coming from the acid. We know this is coming from the base, right? So it's going to be something from a reaction of, let's say, calcium hydroxide or calcium oxide, something like that, and HCl to give us CaCl2, should be Cl2, and water. Do you understand the point?
Yeah.
Similarly, let's take an example of nitrates, because we, in our definition, we also wrote about nitrates. So NH4 and 2SO4. Let's take this. This is ammonium sulfate. This is called ammonium sulfate, right? So if you look at ammonium sulfate, we know that sulfate is for sure 2 negative, right? So this ammonium, because they need to compensate for this -2, then that, and they have two of them, so it must be one positive, and so if there are two, the oxidation state is going to be 2 negative, right? So the positive part are always from the bases, and the negative, which is anions, are always from the acids. So sulfate, definitely what comes to our mind? Hmm? What can come to your mind?
With what?
With
Say that again.
what type of acid would sulfate be? Sulfuric acid, right?
Yep.
Right? Sulfuric acid, like in this case, we were able to see that it was chlorine. One of the anions was chlorine, and chloride or chlorine chloride comes from what type of acid can it come from? They always come from acids, right? The anions always come from the acids. So what type of acid it would be that has given chloride ions to the calcium? So definitely it is going to be HCl. There's no other acid that we have studied, right? And similarly, if the sulfate ion, do you get my point? What are we talking about? We have already talked about that a salt consists of a cation, which is going to be positive ion, and an anion, which is the
Mhm.
negative ion. We have already talked that the anion or the negative ion comes from the acid, and the cation, sorry, anion comes from the acid, and the cation or the positive ion comes from the base in an acid-base reaction, because we know it is the acid and base reaction that makes salt, that gives salt, right? So this is a salt. Do you understand? This is the salt. This is a product. This is a product of acid plus base reaction. This is making sense? So what type of acid it would be that has given Cl negative chloride ion? And definitely it's going to be HCl. And what type of base it is going to be that has given sodium? It could be Na2O or it could be NaOH. Do you understand this now?
Yep.
Are you sure? Is this clear?
Yeah.
All right, alhamdulillah. All right, so if you look at it now, so we are talking about another salt, which is ammonium sulfate. This is the salt we are talking about. And we are saying that this is the cation that is present here, and this is the anion. So this cation would have came from any base. This cation would have came from a base. And this anion, which has a negative sign, -2, would have came from this anion, would have came from an acid. So what type of acid it is going to be with which the base has reacted to give ammonium sulfate? So we know the acid for sure is going to be H2SO4, the acid which has given this ammonium sulfate and water. Do you understand? And the cation, or the base that gave this cation, this ammonium ion, is going to be ammonium. You understand? Base that made the origin of this cation. Do you realize this? Are you able to comprehend all of this like that?
I need you to repeat the last part.
Which one? The equation?
Yeah.
We are saying that this is a salt, right? This is a salt which is called ammonium sulfate. Whenever we look at a salt, the salt is going to have a cation and an anion, right?
Yeah.
So when we look at the anion, we know that anions are always coming from the acid. Anions, they always make up their way up to becoming a salt by an acid, right? Acid is the one that
Mm.
contains that anion that has been passed into the salt. So can you think of acids that have this sulfate ion in them? Obviously, H2SO4. This is the acid that you have studied that has this anion, sulfate ion, that has become the part of this salt, right?
Mm-hmm.
The other part of the salt that when we look at it is always a cation, and cations, they come from bases.
Mm-hmm.
So what would be the base from these ammonium ions have made up their way up to becoming becoming a salt? We would have to trace that, and we know that it is the ammonia that actually is the ammonia is one of the bases that actually gives the cation in form of this sign. Do you understand? Is that clear?
Yeah.
If you need another explanation, don't worry, go ahead, because there's something that they might trick you in an exam with all of this.
Yeah.
Do you want me to explain this again?
I'm sorry. Yeah.
Oh, no, no problem. What we have been talking about up till now is that whenever you come across a salt, let's say you came across a salt which was magnesium
Mm-hmm.
sulfate. What are the two components? Is this an ionic compound or a covalent compound?
Sorry.
Is this an ionic compound or a covalent compound?
Ionic.
Why is it an ionic compound?
Because
Because it has two components,
yeah.
right? This is the cation, magnesium, and this is the anion, sulfate, that is present over there. How would this salt be formed? How in this world are the salts formed? by acid base reactions, right? Acid carbonate
Yeah.
reaction. We are only talking about, at the moment, we are talking about acid base reaction.
Okay.
So we have already understood that the cation ions in a salt always come from the base or the
Mm.
carbonate,
All right.
base or the carbonate. And anions in a salt always originate, or they come from the acids that have reacted with the base or carbonate.
Mm-hmm.
All right, from acid, from base,
Yeah.
right? So
Mm-hmm.
if you were asked to create an equation that would have created this salt, would you be able to do it?
Yeah, I think
How?
you'd use mash.
Hmm? You can do that simply by looking at the components of the salt itself.
Yep.
If this part is coming from the acid, what type of acid would that be? Hmm? What type of acid would that be? Can you name any acids that have sulfate in them?
Sulfuric acid.
What else have acid have you studied that has sulfate ions in it? None.
Mm.
There's only sulfuric acid that is there.
Yep.
So you know one of the reactants to make magnesium sulfate is going to be
Sulfur.
sulfuric acid. And
Yep.
now we know that magnesium ion would have came from any base. How many bases can it be? There can be only two bases for magnesium ion. That is going to be magnesium oxide and magnesium hydroxide. Right?
Mm.
So it's going to be either a magnesium oxide that has reacted with magnesium sulfate to give, that has reacted with sulfuric acid to give magnesium sulfate, or it is going to be magnesium hydroxide that has reacted with sulfuric acid to give you a magnesium sulfate and water. That is it.
Mm.
This is what we were talking about.
Okay.
By looking at the salt, if you look at sodium chloride, can you tell what are the two substances that would have reacted to produce sodium chloride?
Yeah, sodium and chlorine.
No, wrong.
And sodium hydrochloric acid, sorry.
It could have been sodium.
Mm.
Could have been sodium. It could have been sodium oxide. It could have been sodium hydroxide. Any one of them would have reacted with chlorine to give you a salt of sodium
Oh,
chloride.
you mean it like that? Oh, okay, okay.
And whatever it is, if it is reacting with these two, it would have been, if it is reacting with these two, it would have been water. If it was only reacting with sodium, it would have been H2, hydrogen
Mm-hmm.
gas. So by looking at the acid itself, you can easily determine, you can easily tell, you can easily tell what type of, so what were the ingredients that would have produced this salt. Did you get it now?
Yeah,
Are you sure?
yeah.
All right. So this is what it was about. This is what we were when we were looking at the ammonium salts, because ammonium salts are type of salts. What are ammonium salts? Some example of ammonium salts. Some example of ammonium salts are ammonium sulfates, we need to know that ammonium ion is NH4 plus. So it always forms a cation. It always forms a cation in a salt. All right. So we have, and what is the source? Source was this ammonium ion. Like in previous, in the previous, just right now we looked at how where the cations are coming from, where the anions are coming from. Ammonium ion particularly comes from ammonia, NH3, which is a base. You understand? And we know all the cations are always coming from a base in a salt.
Yeah.
Get it? It's a very important lecture. Okay, if you think you have missed something, don't worry. Go through it again by looking at the notes. Go through it again.
Yeah.
Right. So ammonium, we have ammonium sulfates. We have ammonium. We're talking about salts. We have ammonium chlorides. Ammonium chloride. All right. We could have ammonium iodides, ammonium chlorides. We could have ammonium nitrates. All of these are called ammonium salts. So if you look at each of those, this is the anion, this which is coming from an acid, which is H2SO4. This is the chloride ion, anion chloride, right? Chloride ion, right? This
Yeah.
whole of it is a salt. This whole of it is a salt. So every salt must have one anion and one cation. So this cation would be coming from an acid. So this anion, sorry, this anion, this is anion. This anions are always coming from acids. So this anion, what type of acid would it be coming from? What would be the acid that this chloride ion is coming from? Can you get it?
Sorry.
What would be the acid from where this chloride ion is coming from in this reaction, in this salt?
Hydrogen.
Hmm?
HCl.
HCl, right? Easy.
Yeah.
What would be the, so every salt has an anion and a cation. This is the cation that it has. This is the anion that it has, right? So we know that every anion is from the acid. So what do you think this anion would be coming from? It is going to be nitric acid,
Yep.
HNO3. Do you get it?
Yes.
And we know that always this ammonium cation is always coming from a base. Cations are
Mm-hmm.
always from a base, and for the ammonium anion, it is, you always find there's always ammonia from it, which it is coming from. So in other words, the reaction would have been like that: NH3 plus HNO3 is going to give you NH4 NO3 plus
Mm-hmm.
H2. Do you get it?
Yeah.
Is it okay?
Yeah.
All right. So let's move on to the another part, important understanding. So generally when we talk about salts, we divide salts into two distinctions. Basically, two ways to divide salts. One way, we say that salts can be divided into two types. Salts
Mm-hmm.
can be hydrated, which are generally crystals, crystals form, and anhydrous. which are generally powdered or dried form. All right, hydrated or anhydrous.
Okay.
So another distinction that we are going to do after this is salts can be divided into two: soluble and insoluble. Right? We are going to write some points about that so that you can look at every salt and you will get to know whether it is soluble or insoluble. But for now, we are going to be doing salts. What are the hydrated and anhydrous salts? When we talk about hydrated salts, first of all, we say that salts we're going to be talking about hydrated salts first. So when we talk about salts, we say salts combine with water to form crystals. We are going to go into the whole complete method of crystallization, right? Crystallization takes place when you boil an a salt solution. You boil a salt solution and then or you heat it and then you put it at a room temperature to cool down. All right. When it tends to cool down, it forms crystals. Why? Because it traps. So when you have put it out to cool down, the water is actually evaporating, right? So the crystals
Mhm.
are so the anions and the cations, as the water particles are moving out, the anions and the cations are coming closer to each other,
Mhm.
and eventually they reform their bonds, attractive
Mhm.
electrostatic attractive forces between the oppositely charged particles, and they also are able to trap some of the water in between in their lattices. So that is what becomes crystals. We are going to be writing about it, don't worry. I just want to give you an overview. We'll write about it when we are discussing salts. So the salts combine with water to form crystals, right? And these water molecules that trapped water molecules that get trapped between the lattices are called is called water of crystallization. Water of crystallization. Very something very important to keep that in mind. Water of crystallization. So this brings us to an understanding. The salts that have water of crystallization, water of crystallization are called hydrated salts. They are called hydrated salts, right? An example could be like the normal salt is copper sulfate, all right?
Okay.
And if there is a water of crystallization, if it is crystallized, it can be
Mhm.
copper sulfate
Mhm.
5H2O. All right, copper
Okay.
sulfate dot 5H2O. What does 5 dot represents? What does this dot represent? Can you tell? This dot. This dot means that if the substance is heated, everything after the dot will evaporate, nearly given off. All right. If the substance is heated, everything after the dot will be given off. This is what it means, this dot.
Mm-hmm.
So we have more examples like there's the let's say magnesium sulfate. Magnesium sulfate. Magnesium sulfate dot 7H2O. What are you going to call this? This is hydrated magnesium sulfate crystal or crystals of magnesium sulfate. Do you understand?
Mm-hmm.
Crystals of magnesium sulfate. This is what it is going to be called, or hydrated magnesium sulfate. You understand? Similar.
Uh,
Sorry, did you get it?
yes, it'll. Yeah.
Similarly, you have another example of zinc sulfate, like that. So these are the hydrated, which are the crystals.
Mm-hmm.
It doesn't mean that if you pick them in your hand, you're going to see a lot of water coming out on your hand or you're going to feel wet. You have to keep in mind they are dry. They are dry. They're just like crystals. They are dry, like salt, right?
Mm-hmm.
They are dry, but they have water in them. Very few of the molecules only. You get it? That is why
Mm-hmm.
they have formed crystals. And you see, that is why crystals are see-through because that is why they are transparent because there it is only water between the lattices. Do you understand?
Mm-hmm.
On the other hand, for the anhydrous, if you talk about anhydrous, just remove this right now. So if we're going to talk about uh, anhydrous, anhydrous are the one which have they do not have water of crystallization in them. All right, not
Mm-hmm.
contain water of crystallization. That is why they are called anhydrous ones. And most of the time they are powders
Okay.
in a powdered form. All right. This is also one of the tests for water. Do you know how do we really test water? Test for water. You can just write it over here quickly. Test for water. How do you write test for water? Basically, so when you are going to heat when the hydrated salts, you have to keep this in mind generally, when the hydrated salts are heated, they give off water of crystallization and they form powders, right? One of the tests for water is that the copper sulfate copper sulfate is actually white powder, solid powder which is white. When you add water with it, or if there is a water in somewhere, and you put some of the copper sulfate, it is going to turn this copper sulfate is going to turn blue,
Mm-hmm.
going to turn blue. You understand?
Mm-hmm.
Now this has become anhydrous. It tells for water. Now, if you would have to heat, if you're going to heat copper sulfate, so what it has absorbed, it is a crystal, right? And crystals they have water of crystallization.
Mm-hmm.
Is the water of crystallization, right? So if you were to heat copper sulfate crystal, it would turn back into white, solid. This is also solid. It is in blue. This is going to turn white.
Mm-hmm.
This is blue. You understand why most of the water has evaporated? Because of the heating. Do you get this point?
Mm-hmm.
This is clear. Should we move to soluble, insoluble?
Can we call it a day here? I'll have to.
It's just going to take 5 minutes, inshallah.
Can you zoom out 1 second?
I
I need.
would suggest you can just copy that from the video if you would want to.
There's a video.
Yeah, I'll share the video with you. This video.
Oh.
All right. Just copy that from there,
Mm-hmm.
and then I'll just quickly share with you. Or if you want to take a picture, you can take a picture right now.
Mm-hmm.
So you have both of them, the video and the picture, the screenshot.
Okay.
Done?
Can you go down? Okay.
All right. The salt preparation would be left. That is the one part. We'll just quickly go through this distinction of salts. Salts we have already talked about can be divided into two: soluble salts and insoluble ones. All right. We know that salts are basically ionic compounds, and most of the ionic compounds are soluble in water. But that's not the case for all of them, right? There's a certain understanding that we need to have when we talk about soluble salts. We say something. This chart is going to be very helpful for you, inshallah. We say that all salts of sodium, potassium, ammonium are or soluble. Okay, are soluble. You get it? All salts of, it's in the soluble section anyways. all salts of sodium, potassium, ammonium are soluble. Secondly, all salts of nitrate are soluble. All right. Then we say all chlorides are soluble, right? Except except lead chloride and silver chloride, PbCl, AgCl, except, all right. Then we say all sulfates are soluble, except barium sulfate, calcium sulfate, and lead sulfate, PbSO4. You get it? And
Yeah.
then we say all carbonates are insoluble. All carbonates are insoluble. This is what carbonates, the sulfates are going to have this with them, right? Chlorides are going to have this with them. Nitrates are going to have this with them, right? Do you get it? And carbonates are going to have this with them, like this sodium carbonate or magnesium carbonate, let's say, right? All carbonates are insoluble except sodium, potassium, ammonium. You get it? This is the chart that you need and you will be asked about a lot.
Okay.
It's just simple. All sulfates, all chlorides, all nitrates, all salts of sodium, potassium, and ammonium are soluble. Some chlorides are insoluble, Pb and Ag. Some sulfates are insoluble, like barium, calcium, and lead. And all carbonates are insoluble except sodium, potassium, and ammonium. Very easy. You get it? It's
Yeah.
not going to be difficult. We are going to say that so many over and over and over again, so many times. If you go through the previous videos of salt, I've and all of those soluble ones are going to get this sign, aqueous. All the insolubles are going to get this sign, S, which is also called a PPT, precipitate. Okay,
Mm.
this is clear. Inshallah, let's call it a day here, and then I'll see
No.
you tomorrow, inshallah.
Okay.